Welcome to this explainer. Today, we're diving straight into the Cognifyz Data Analysis Internship program from start to finish. Think of me as your senior mentor for the next few minutes. We're going to break down every single task, explore the dataset, dig into the Python code, and most importantly, get you right across that finish line. Because look, the goal here isn't just to write scripts. We're building a polished, professional portfolio piece that absolutely proves you can bridge that gap between raw technical skills and real-world business intelligence.
So here's our game plan. First, we'll do an introduction and dataset overview. Then we hit level 1, which is foundational analysis. Next up is level 2, our intermediate analysis, followed seamlessly by level 3, advanced insights. Finally, we'll wrap up with organization and libraries and finish off with your final submission and showcasing.
All right, section 1, introduction and dataset overview. To kick out this internship journey, we really need to equip our tools and properly survey the map.
So our raw material here is a comprehensive multi-column restaurant dataset. To actually wrangle this wealth of information, we'll be firing up Python alongside industry heavyweights like Pandas, NumPy, Matplotlib, and Seaborn. The second we load that CSV file into Pandas, we can immediately pull up the first few rows, carefully check for missing values, and verify all our data types, just to ensure a super clean workflow. This isn't just basic prep work, guys. This is exactly where we start revealing those hidden business insights trapped inside critical columns like aggregate rating, price range, and online delivery.
Moving right along to Section 2, Level 1, Foundational Analysis. Let's dive in and actually start translating our code into crucial business insights.
Our very first task? Identifying the top cuisines. By whipping up a simple count plot, which is an absolute breeze with a library like Seaborn, we can instantly spot the top 3 cuisines and rapidly calculate their exact market share percentages. We'll also take a hard look at the highest-rated cities, which gives us an immediate pulse on core customer preferences across different regions. Remember, we're not just writing code to count rows here. We're figuring out exactly what food dominates the market and pinpointing precisely where the happiest customers are eating.
Next, we gotta follow the money. We'll use histograms and count plots to analyze price range distributions. Doing this transforms basic percentage math into a crystal-clear visual picture of customer spending behavior. Are most of these spots budget-friendly, or are they catering exclusively to luxury dining? The histogram gives us that answer in a split second. That's exactly the kind of actionable data you'd need if you were consulting a client on how to competitively price their brand new menu.
Now check this out. A clean donut chart brilliantly shows us the percentage of restaurants offering online delivery versus those that don't. But to add real analytical weight here, we take it a step further. We compare this delivery metric directly against our aggregate ratings. Does the convenience of online delivery actually drive higher customer satisfaction, or do dine-in-only experiences score better? Visualizing this directly hands us a definitive business conclusion that stakeholders absolutely care about.
All right, Section 3, Level 2, Intermediate Analysis, uncovering deeper restaurant trends. Now that we've totally mastered the basics, it's time to step up the complexity.
Here we're zooming in on the power of scaling. We'll identify restaurant chains, specifically the ones popping up multiple times in our dataset, and contrast them directly with independent single-location spots. The goal? To answer a critical business question. Does having multiple locations and aggressively scaling up correlate with higher average votes and overall popularity? Or, do those charming, independent local spots actually hold higher ratings thanks to unique customer loyalty?
Let's move on and see how this builds directly on our Level 1 cuisine analysis. Instead of just looking at single cuisines in a vacuum, we'll use Pandas to split the text data and find popular combinations. We are hunting for those exact flavor pairings that consistently drive the highest average ratings across the board. Honestly, this is the kind of highly specific, actionable insight a major restaurant consultant would easily charge thousands for.
The final task for Level 2 introduces geographic clustering. By mapping out the latitude and longitude columns inherent in our dataset, we can visualize exactly where these restaurants are physically located out in the real world. This lets us pinpoint dense restaurant hubs. And why does that matter? Well, understanding geographic density tells us pretty much everything we need to know about local competition and potential foot traffic. It definitively proves how location directly impacts a restaurant's bottom line.
Okay, Section 4, Level 3, Advanced Insights, tackling NLP and multivariable correlations. We've officially reached the most advanced stage of the program. So if our dataset includes review text, we get to dive into some deeply fascinating natural language processing. By cleaning up that text, which basically means writing scripts to drop comma and stop words and strip out messy punctuation, we can pull out the exact frequencies of positive versus negative words. We can even run a correlation analysis to see if the physical length of a review ties back to its overall rating. Like, do angry customers write more? Do completely happy customers just drop 5 stars and say nothing at all? This advanced text analysis definitively answers those behavioral questions. We also need to single out our absolute highest and lowest voted restaurants. By plotting total votes against aggregate ratings on a scatterplot, which again is a total breeze with Seaborn, we can prove whether or not there's a real statistical correlation between the sheer volume of engagement a restaurant gets and the final rating it ultimately receives. It visually shows us if raw popularity actually equates to quality. Finally, we'll group our various charts to see how different premium features dynamically interact with each other. We want to know, for instance, if higher-priced restaurants are far more likely to offer advanced table booking versus standard online delivery. This hands us a crucial conclusion about premium dining experiences. Usually, luxury means dedicated in-person table service, not delivery in a cardboard box. Our grouped Python charts will rigorously verify if the data actually backs up that industry assumption.
Moving to Section 5, Organization and Python Libraries. Structuring your project. Analyzing the data is incredibly fun, no doubt, but formatting your work professionally, that is exactly what separates an amateur student from a highly successful intern.
Keeping your digital workspace relentlessly organized is absolutely essential. You want your code squeaky clean and your notebooks well commented. So, structure your project folder starting with the raw dataset. Follow that up with your level-wise Jupyter notebooks, meaning one dedicated notebook for level 1, another for level 2, and so on. Make sure to include a specific images folder for all those awesome Seaborn charts we just generated, a detailed README file, and your final PDF report. Trust me, stakeholders love pristine organization just as much as they love good data.
And finally, Section 6, Final Submission and Showcasing. Claim your reward. You've done the hard work, you've carefully written the Python code, and you've found the insights. Let's walk through crossing that finish line.
Before you submit a single thing to the program, heavily double-check this submission checklist. Make absolutely sure your final zip file contains your source code, the original unmodified dataset, visual screenshots of your graphical outputs, and your detailed PDF report. And please remember this golden rule. Fiercely explain the business insights in your report, not just the code. The stakeholders want to know what the data mathematically means for the business, not just how you typed out the Pandas syntax.
The last and arguably most critical step for your entire career trajectory is showcasing. Record a concise project demo video where you confidently walk through your findings. Upload that directly to your LinkedIn profile, tag Cognifyz Technologies, and throw in the right internship hashtags. This publicly and powerfully validates your new skills to passing recruiters. It proves you don't just know how to write complex code, but that you can actually communicate complex data clearly to a general audience. So, you've successfully navigated all the way from raw, unstructured data to advanced, actionable business intelligence. With these highly practical Python and visualization skills under your belt and a beautifully organized portfolio piece totally ready to share, you have a massive advantage over the competition. So, the only question left is, are you going to let your brilliant insights sit unseen in a zip file somewhere on your desktop? Or will you actively leverage this entire experience to launch your next big career move? Thanks for tuning into this explainer, and happy coding!